That depends on what he's doing.
Yeah.
He shouldn't. Right now, the time frame of most scientists is very short, and it harms them. The granting system, the government granting system, requires constant reporting, constant competing for the next year's money, and so forth and so on. So scientists tend to publish almost monthly. They publish and publish and publish because the grant requests have to show a big, long line of publications. And I would say it's conservative to say that half the money of all the senior scientists, half the time of all the senior scientists in the country, it goes into generating publications and making reports that are all premature because you just don't make discoveries every day. An interesting comment was made by a few years ago by a man who won the Nobel Prize in chemistry. His father had won the Nobel Prize in chemistry earlier, and they said, "What had made it possible for you to do this? How'd you manage? Was it easier because your father got a Nobel Prize?" And he says, "Well, the big thing was that because of my father's Nobel Prize, I was able to work for 5 years with nobody bothering me and get the job done." So most scientists work under such short time frame intervals in order to make all these reports to the bureaucrats that are telling them what to do, that it makes it difficult. It's better, in most cases, the great advances in science of the past have mostly been made by men and women who fell in love with the subject, lived and breathed that subject for years until they understood it thoroughly, and then made some important discovery as a result of that devotion to the problem. And so scientists really should work in a relatively free environment where they're free to work for years because it's not easy to discover new things. Putting them under pressure doesn't really help. It actually hurts them. And one of the ways our current scientists are hurt is that they're under enormous pressure, and that leads to all kinds of problems.
Where are you at, and are you able to share how it's going for you right now with regard to the discovery of a molecular clock, and what are the positive life-giving ramifications as that discovery unfolds?
Well, we work on both. In molecular clocks, the biochemistry is going very well. We wrote a book about this. We've written a lot of good papers. It's a wonderful field to be in, and we're doing quite well. In terms of direct application, we just published a paper on the molecular clocks and the protein that is most implicated in Alzheimer's disease and Parkinson's.
My mother had Alzheimer's and died last year.
I'm not telling you we cured Alzheimer's.
Right.
But there's a protein, alpha-synuclein, which is found in large amounts precipitated in the brains of the victims of these two diseases. And no one knows why it's present in large amounts in precipitated form, but there's so much of it there that it is impeding mental function. It may be symptomatic of what causes these diseases, or
right.
It may be a primary part of the cause. There's lots that's not known. But it is known this protein is a seminal part of these two diseases. Well, we studied, it took us about a year, and we learned all that was needed to be known about the molecular clock that's running, clocks, two of them, that are running inside this protein. And when we published it, that told the protein chemists all over the world that are working with it something new about the molecules they're working with. And it may, in fact, have value for them because we now know a little more about that protein than we did. So you see, we were working on our molecular clocks, but we chose a protein to do the work on that had medical
implications.
So you don't. The best thing you can do is to have scientists, if they can, to work on something that is of scientific value, fundamental value, but also has some value to the people who are paying for the work.
I have something interesting to share with you about the molecular structure of something that took me by surprise a year ago. There's something called birch tree sugar that is explained as being very different as it metabolizes in our bodies on a molecular level, such that diabetics can use it. It's not like regular sugar. And when I heard that, I thought it was fascinating. And I'm wondering if you could explain, A, what a molecule is, even though it's late in the conversation, and how that could be so.
Well, I don't know anything specific about the sugar you mentioned, but a sugar is a class of molecule. There are thousands of kinds of sugars. Sugar means to an organic chemist a certain particular kind of molecule. Sugar molecules usually have a ring, and the rings aren't always in ring form, but one way they're drawn and they exist in a ring form. There's a ring of 5 or 6 carbon atoms, and then hydrogen atoms and hydroxyl molecules are stuck on the sides of them. The molecules have molecular weight of 300 or 400. They're metabolites. And your body contains a lot of different kinds of sugars. The table sugar that we eat is a dimer of 2 sugars, glucose and fructose. First thing that happens when you eat it is that your body hydrolyzes it in the stomach and it's turned into fructose and glucose. And then those are further used or metabolized in your body. So these are small molecules. Sugars are metabolites. Virtually all the naturally occurring sugars are metabolites of either plants or animals. And diabetics have trouble metabolizing the sugar that is normally present in food, so they need help. It wouldn't be surprising to me that there's a sugar that they could metabolize, and that seems to be what you're talking about, but I don't have any special knowledge about that sugar.
Right. And the other question I had for you about this metabolic clock is, if this exists vis-a-vis your research, could we say that the molecular clocks, by virtue of the fact that they're there, make molecules almost intelligent? Does that make sense?
I'm very sorry. Would you repeat that? Because
sure.
the scene went on behind me for a minute.
Sure, no problem. In other words, because a molecular clock has been discovered and is functional, could it be said also then that molecules are intelligent or have an intelligence in them?
No, I don't think so. What we would call intelligence, you could say that if you were trying to get attention with your book, but with a book you were writing. But I don't think there's much.
But what would you refer to it as? Because obviously there's some type of in other words, it's more intricate than we thought, and it's more active.
I build a machine.
Yeah.
Suppose I want this machine. Well, you got to watering your lawn, and you got a timer in the back with a clock in it that decides when the lawn will be watered. This clock regulates the water system. Now, that's a clock. It doesn't mean intelligence, but it just does things when it's scheduled to do them. One of the clocks, one of the ways in which the reaction, my son and I worked together on this, and he worked out a way for calculating the rate at which these clocks would run in proteins when the three-dimensional structure of the protein was known. This was greatly helpful to an advance that was made at Washington University in St. Louis. They found that when the DNA in a cell was damaged by radiation or some other thing, one of these clocks that we study started running. And the clock had about a 24-hour time span on it. If the clock ran out, the cell was killed. If the DNA was repaired properly before the time ran out, then the clock was reset and the cell continued to live.
That's fascinating.
This was a little clock built in there to time the DNA repair mechanisms, and if they were too slow to kill the cell so you wouldn't have a defective cell around. And the clock was one of these clocks we work on. It was built into a protein. And because of our work, the scientists working on it could know how fast their clock was running. So this is a timed process. You could say the molecule was a little more intelligent because it had a timer in it. I think the word intelligence might be a little high-flown for the clock.
I totally understand. I read about the fact that you lost your wife when she was not able to get into the hospital, and how you didn't have any type of these miniature devices to check what was going on. Can you explain that? And I'm very sorry about the loss of your wife, but share it.
Wasn't actually, she couldn't. My wife, Laura Lee, was a computer